Hi friends, my name is Brooke, and I want to thank you for joining me to practice some math today. Today we'll be working on properties of exponents. So what's tricky about this lesson is that it's really a matter of memorizing what to do when we see different types of problems that have exponents in them. So we will go over all of the rules or properties of exponents first, and then we will practice some problems that are all mixed up together, and we will see what we need to do when we see these different types of problems. Here's our first rule. So when we see multiplication problems that have exponents, we can call it multiplying powers, and this is what we'll do. The base, which is the big number, will stay the same, and we will add the exponents together. So our base is 3 in this problem. We keep the 3, and then we add up the exponents. 4 plus 5 gives us 9. 3 to the 4th power times 3 to the 5th power is equal to 3 to the 9th power. We can leave our answer just like this. Next up, I see 7 to the negative 2nd power times 7 to the 4th power. We'll talk more about negative exponents in an upcoming rule, but for now, we will follow the steps that we see for multiplying powers. We should keep the base the same, so we copy down the big number, and then we add up the exponents. Negative 2 plus 4 gives us a positive 2. Here's one more example of multiplying powers. We keep the base the same, so I'm copying down my 2, and then I need to add our 3 plus our negative 1. 3 plus negative 1 gives us 2. So we will practice more of these problems in a couple pages, but for now I'm going to continue to introduce our rules to you. Here's another type of problem that we'll see today. This next rule is all about dividing powers. This time, if we see a division problem, the base or the big number will stay the same. We will write the big number. Next, we will subtract the exponents. So on this problem, 4 to the 6th power divided by 4 to the 5th power. We copy down the 4, the base stays the same, and then we subtract the exponents. 6 minus 5 gives us 1. One thing to know is that in algebra, our 1s are usually invisible. So 4 to the power of 1 is really the same as 4. Here's another one. This one's a little trickier. We see some negative exponents. So we keep the base the same whenever we are dividing. Keep the base the same. And then this time, since it's division, we need to subtract. So the problem that we are doing is negative 2 minus negative 5. So you can think through your rules from Math Foundations, and we can say keep, change, change. We keep the negative 2, change from a minus to a plus, and change from a negative 5 to a positive 5. Since they have different signs, we subtract the numbers. 5 minus 2 gives us 3. And it will be a positive 3 because our higher absolute value was positive. So this is really a final answer of 6 to the 3rd power. That's our answer. Let's look at this last example. We've got 3 to the 3rd power divided by 3 to the negative 1st power. So we've got more negatives to work with. The base stays the same, and whenever we see a division problem, we subtract the exponents. So we are doing 3 minus negative 1. we can say keep, change, change. We keep the 3, change from a minus to a plus, and change from a -1 to a +1. 3 plus 1 gives us 4. So now I know that my final answer is 3 to the 4th power. We'll continue to practice a few more rules, and then we'll apply them together. This next rule is called the power of a power. That's when we see an exponent in parentheses with an exponent on the outside. So for step 1, the base will stay the same. We will copy down the big number or the base again, and then this time we are going to multiply the exponents. One way that I remember to multiply is because I see parentheses, and in your previous lessons, we learned that parentheses mean multiplication. So I am just going to copy down the big number, and then we multiply to get our final answer. 4 times 3 gives us 12. Same thing, I see parentheses, so that reminds me that I need to multiply when I see problems like this. I need to keep the base the same, copy down the 5, and then we'll multiply 2 times 2 to get 4. One last example, we are going to keep the base the same, so we copy down the 2, and then we will multiply the exponents. 5 times 4 is 20. So these are a little tricky right now, but we will practice lots of these. I am giving you examples of each rule, and then we will have a page where we will apply all the rules and practice these again. For now, I am going to continue on. We'll talk about exponents of 0. Anytime you see a number raised to the power of 0, it will always equal 1. So here I've got 6 to the power of 0, that equals 1. These next problems are an extra challenge. To do these problems, we need to apply the rules that we've already learned. So I see multiplication. I know that when I see multiplication, I need to keep the base the same, and then I need to add the exponents. 2 plus -2 is 0. So now I see 2 to the power of 0, and I know that that is going to equal 1. So this problem was extra challenging because we needed to apply 2 rules that we know. We had to know how to multiply exponents, and we also had to know what to do when we see a power of 0. So our final answer is still 1. One more problem like this. I see division, so I know that I need to keep the base the same, and when we see division, we are subtracting the exponents. So -3 minus -3. So we use the phrase keep, change, change. That is really -3 plus a +3. And those cancel each other out to give us 0. So this is another 4 to the power of 0, which equals 1. Here is one last rule to remember. So looking at this last rule, this is all about negative exponents. And so whenever we see a negative exponent, it is equal to the reciprocal of the base raised to a positive exponent. So this word here, reciprocal, is a little tricky. We will think through this word first, and then I will show you a shortcut on these problems. So a reciprocal is a number or fraction that you need to multiply a different number by to get back to 1. So here are some examples. If I have the fraction 1/4, I'm asking myself, what do I multiply 1/4 by to equal 1? And the correct answer to that is 4. So 4 is the reciprocal of 1/4. Here's another example. Let's say I have the fraction 1/2. To get my reciprocal, I am asking myself, what do I multiply 1/2 by to get 1? I need 2 halves to get 1. So 1/2 times 2 equals 1. So these are examples of reciprocals. 1/4 is a reciprocal of 4, and 4 is a reciprocal of 1/4. 1/2 is a reciprocal of 2, and 2 is a reciprocal of 1/2. So those are our pairs that go together. So we can apply this pattern to our problems. I notice that when we have a number and I'm looking for a reciprocal, the number matches at the bottom, and we just put a 1 and our fraction bar up top. So that's the shortcut that we will use as we practice these problems. On all of these problems, we are looking for a negative reciprocal. So to find our reciprocal, we are just going to put a 1 up top, and then we are going to write the power in the denominator and ignore that negative sign. That gives us a negative reciprocal. So this is our final answer to simplify 2 to the negative third power. These mean the same thing. My answer, again, needs to be simplified as a negative reciprocal. So our reciprocal will always have a 1 up top, and all we do is make our exponent positive in the denominator. So 1 over 3 to the 4th power is our final answer. This one is a 2-step problem, so it's giving us an extra challenge. I see division, so I know that I need to subtract. I'm going to keep the base the same, and then 3 minus 5 gives us -2. So now I am seeing this negative exponent. To simplify a negative exponent, I need to write a negative reciprocal. So I'm going to put a 1 up top, and then instead of 2 to a negative second power, we change the sign. We make it positive. We can write 2 to the second power, and that will be our final answer for this box. We will try some problems together. I do encourage you, as you start getting more confident, to pause this video and try some on your own so that you can test your memory. But we'll do some together here on the screen. So number 1, this dot in the middle means multiplication. So I need to know what to do whenever I see a multiplication problem. So if we think back to those multiplication problems, we know that we should keep the base and we should add the exponents. So I'm keeping the base, or the big number, the same, and I'm adding up the exponents. 4 plus 3 gives us 7. Final answer is 2 to the 7th power. Number 2 is very similar. I see that dot in the middle again, and that means multiplication. Whenever we are multiplying exponents that have the same base, we keep the base the same, and we add up the exponents. 3 plus 4 is 7. So again, our final answer on this problem is also 2 to the 7th power. Let's try out number 3. We see multiplication again. We are multiplying exponents that have the same base. So that means we keep the base the same. 3 is our base. And again, we add the exponents. 4 plus 3 is 7. Here's another multiplication problem. That dot in the middle means multiplication. So I'm remembering my multiplication rule, which tells me to copy the base and add up our exponents. 4 plus 4 gives us 8. We'll take a look at the next page as well. I will have all 20 problems here on this video, but again, I challenge you to try some out on your own so you can start testing your memory of these rules. But here's number 5. We see multiplication again. We have the same base, so we know that our rule tells us to copy down that base and add up our exponents. 2 plus 5, of course, gives us 7. So final answer for number 5 is 4 to the 7th power. Here is number 6. One last multiplication problem. We practice this rule. We know the base stays the same. We copy down the base and we add up the exponents. 2 plus 4 gives us 6. Number 7 is switching over to division. Our division rule tells us to keep the base the same and subtract the exponents. 8 minus 3 gives us 5. So I'm copying down my base and again subtracting. 8 minus 3 gave us an exponent of 5. Number 8 is division as well. Every time we see division, we keep the base the same and we subtract the exponents. 3 minus 2 is 1. We talked about how 1s are usually invisible in algebra, so we can leave our final answer as just 9. Here is number 9. So this looks tricky, but it's really another example of division. You have seen a division sign like this before in previous courses. So if you took Math Foundations, this is division. This is the same as 8 to the 4th power divided by 8 to the 1st power. This is really the same as just a regular 8. But since we see division, we know that we keep the base the same and we subtract the numbers. 4 minus 1 gives us 3. Here is number 10. This is another division problem. This is the same as 4 to the 8th power divided by 4 to the 4th power. So we know that we should keep the base the same, and since it's division, we should subtract the exponents. 8 minus 4 gives us 4. I see a couple more division problems here on numbers 11 and 12. One thing I know right away is that we see the same thing on the top and on the bottom. So this actually just simplifies to 1. This was the same as 2 to the 3rd power divided by 2 to the 3rd power. So you could, maybe you could have noticed that it was equal to 1 because they were the same on the top and on the bottom. Otherwise, you may have to go through all of the steps. This is the same as 2 to the third power divided by 2 to the third power. So whenever we see division, we know that we should subtract the exponents. We keep the base the same, and then 3 minus 3 gives us 0. Anything to the power of 0 is equal to 1. So that's another way to find your solution. You might be able to get directly to the answer when you see that match on the top and on the bottom. Otherwise, you can use your exponent rules to get to your final answer of 1. Here's another division problem. We see 8 to the fourth power divided by 8 to the second power. We know that when we see division, we keep the base the same and we subtract. 4 minus 2 is 2. So our final answer is 8 squared. Next, we're trying out our different type of problem. This is the power of a power rule. So one thing that can remind you of what to do is your parentheses. We know that when we see parentheses, it means multiplication. So on problems that look like this, we keep the base the same and we multiply the exponents. 4 times 4 gives us 16. So 3 to the 16th power is our final answer. Here's number 14. Again, I see parentheses, so this is the power of a power property, and we keep the base the same, and again we multiply 3 times 2 to get 6. Here's number 15. We see parentheses, so we keep the base the same, and we multiply. 4 times 3 is 12. Here's another with a power of a power property. We keep the base the same, and our parentheses tell us to multiply. 3 times 3 is 9. Here are our last 4 problems. So these have negative exponents. So as we think about these, we are thinking about reciprocals, or you can also think of it just as a shortcut. Either way. But as I look at the number 2, if I ask myself about a reciprocal, I'm trying to think about what fraction I would multiply 2 by to get a positive 1. I would need to multiply 2, which is the same as 2 over 1. I would need to multiply 2 times 1/2 to get 1. We can see 2 times 1 gives us 2, and then 1 times 2 gives us 2, which is equal to 1. So 1/2 is the reciprocal of 2. We always need to end up with an answer that has a 1 up top. So I'm thinking about my 1/2, and then I change from a negative 2 in the denominator to a positive 2. So my final answer is 1 over 2 squared. We'll try another one. Let's try out number 18. We will think through the word reciprocal one last time so that we can understand that shortcut. So thinking about the number 8, 8 is the same as 8 over 1. We know that whenever we simplify a negative exponent, we always need to turn it into its reciprocal, and then we need to make that exponent positive in the denominator. So the first thing I need to do is find the reciprocal of 8, and I know that 8 is the same as 8 over 1. To find my reciprocal, I'm asking myself, what do I multiply 8 or 8 over 1 by to get 1? And my reciprocal is going to be 1 over 8. your reciprocal is just like flipping this fraction upside down. We're flipping the numbers over. I see that 8 times 1 is 8, and 1 times 8 is 8. So when we multiply those together, we get 8 over 8, which is the same as 1. So our reciprocal was 1/8. So when we write our final answer, we always need our reciprocal with our exponent turned into a positive in the denominator. So there's our final answer. You'll see this pattern. It will always end up with a 1 up top, and then it will have the problem that you see in the denominator, and the only thing that we change is the sign. So now that I've seen that pattern a few times, I can use that shortcut on numbers 19 and 20. My pattern that I saw showed me that I will always need a 1 up top, and then my denominator will look almost the same as my problem. The only difference is that it changes from a -3 to a +3. So my simplified answer is 1 over 7 to the 3rd power. So that is what this equals. Our original problem equals 1 over 7 to the 3rd power. But now we just have it in a different format. We will do the same thing to simplify number 20. Whenever we see a negative exponent, we always need its reciprocal. So that means I'm putting a 1 up top. The reciprocal of 4 is 1/4. So my final answer will just have a +4 as its exponent in the denominator. So that was our last problem in this lesson, and I hope this video helps you out. I would encourage you to continue with these practice problems so that you can practice applying these rules to all different types of problems and kind of get them stuck in your memory. So thank you again for practicing math with me, and I hope you enjoy the rest of your day.